All right, so standard transformation form. So I'm going to write this out. Oh, we're going to turn this thing on. Or else my tablet doesn't work. All right. So if we let f of x be the parent function, then standard transformation is given by g of x equals a, which I'm using a capital A. It's going to be a value. And then f of, and then I'm going to put in a b of x minus, and then c, close that, and then close the function, plus d. All right, so we have the f of, so that's the function. That part's going to change depending on what the parent function is. For example, you could have that g of x is a times b x minus c squared plus d. Right? If it was the quadratic, it would look, oh, I have an extra set of print. I'm missing a print.
Yeah, on the end.
Where is it?
It's after the squared, right?
Yeah, there should be 2 right there, before the squared.
Or sorry,
Right there. So if you have quadratic, it looks like that. Or you could have, I'm just going to do one more. I'm not going to go through all of them. Don't worry. If it was the square root function, then you'd have that, and then b, x minus c, and then plus d on the outside. So in the standard form, it's showing f of x because you don't know what, it depends on the function, the operation of the function. And if we look at the a value, a is going to represent vertical dilation. So if a is greater than 1, if a is greater than 1, then you're going to have a vertical stretch by a factor of a. I'm going to make the absolute value. Because if it's negative, then that's going to be a reflection. So we're just looking at the a value. And then if we have 0 less than the absolute value of a less than 1, so if the absolute value of a, the positive version of a, is between 0 and 1, that tells you have a vertical compression. By a factor of 1 over a.
Wait, why is it a vertical compression?
Because the a value is less than 1 but greater than 0, so like half.
Okay, yeah.
And then next we have b. B is horizontal dilation. So if b, the absolute value of b is greater than 1, Then you have horizontal. Which one is it?
Horizontal stretch?
Yes.
Stretch,
Or
right?
compression. Is it stretch or compression?
Because it's greater, right?
Yeah. By a factor of b, and if 0 is less than the absolute value of b, is less than 1, then horizontal,
Compression.
exactly, horizontal compression. By 1 over b. And then what was the next letter? Is C. So if C is going to be your horizontal translations. So if you have x minus c, I'm just going to do it that way. If x minus c means you shift right, and if x plus c, then shift left. Yeah, fine, then left. That's fine. And then your d value at the end was the vertical movement or translations. So if you have a positive d, then shift up. And if negative d, shift down. Okay. So now I'm just going to go over 3 examples of what your work will look like. And again, I know that you guys already know these things, but we went over it again. So if, for example, you were given that f of x, I don't like calling it f of x. So if we're saying the parent is, we're going to call it g. G of x equals negative 3 over 2 plus 2x and then minus 1 on the outside. And you're going to need to state the parent and describe the transformations. So you give f of x and then describe the transformations that happen. So you can tell, well, first let's go ahead and rearrange it to where it matches the g of x we gave up at the top. So one thing we would want to do is take out a common factor in the denominator. So make this g of x equals negative 3 over 2, and then move the x to the left, make it x and then plus 1. So rearrange it and bring the 2 out of the denominator, or out of the factor out of 2 in the denominator, and leave the minus 1. And then we can go one step further and bring the negative 3 halves out front. And so I'll do negative 3 halves like that, and then 1 over x plus 1, and then minus 1. All right, so the parent function, this is the reciprocal function, so 1 over x. So I state the parent and then list the transformations. So the negative tells me that there's a reflection across,
x-axis.
yes, the x-axis. And then 3 halves, what is that telling you?
So no,
It's minus 1.
the vertical compression.
3 halves, is it greater than 1 or
It's less.
less than 1?
Or no.
3 over 2.
It's over.
It's a stretch, right?
Stretch. Oh.
Yeah, my bad.
Vertical stretch.
Because it's over here.
Yes. By 3 over 2, because 3 over 2 is like 1.5, so it's
Yeah.
greater than 1.
You're right.
And the next one is,
Last one.
yep, the x plus 1 means it's going to go left 1. And then the minus 1 on the outside, down 1.
Wait, left one, I thought it was right one. I mean, no, you're right. Sorry, my bad.
Plus, plus, you're good.
Yep, the one with the x is always the tricky one. So this could be in parentheses if it helps. Doesn't matter. All right, second example, m of x. M of x equals 6 plus absolute value of 2 minus x over 2 minus 7, close the absolute value. All right, so first, well, we already know the parent function, even though it's not in the proper order, right? So the parent is the absolute value function. So f of x equals the absolute value x. But we have some rearranging to do. First, this 6 in the front, we don't like it in the front, normally. We would put it at the end. And then on the inside of the absolute value bars, we have a 2 and a minus 7, so we can combine those like terms. So m of x equals the absolute value of negative x over 2 minus 5, close the absolute value, and then plus 6. So there's the first step of rearranging. But this also doesn't match the standard transformation form. We want to bring the, was it A, B, the B value? We want to see the B value. So we want to bring it outside of a set of parentheses. So to do that, we need a common denominator of 2. Right, so if I made this into 10 over 2, y'all see that? Maybe a little bit.
Yeah.
And then we can bring out, I'm just going to change my color, that's a blue one. Negative 1/2. And then leave x plus 10 inside. And all of that is inside the absolute value bars. Yes. And then we have the plus 6 on the outside still. So now we know that this is the B value, and then on the end we had the D value. And that's the C, the 10 is the C value. And what about A? A is whatever's in front, right? There's nothing there, so it's just 1. So there's no vertical reflection, there's no stretch,
So it has to be
it's
one.
just a 1. So we're not doing any sort of transformations there. We do have the transformation of the B value. That gives us a reflection over the y-axis. And there's a horizontal compression by half. So both of these came from the B value. And then we're also going to shift to the left 10. And we're going to shift up 6. And that's it. So that's the transformations. And I'm going to do one more example. This time I have P of t. Still the function.
Thank you.
We have the square root of 2 minus 3/2 t all of that's under the radical, plus 1 on the outside. All right, so we know that the parent, f of x, equals, or f of t, I guess. I'm going to write it as an x. Square root x. If you had t's in there, it doesn't really matter. All right, so we want to get all this stuff into the right order. So p of t is going to equal the square root of, we want to switch them, right? Negative 3/2 t plus 2, and then plus 1 outside. And then we also want to bring the b value out, factor out the b value.
Which is negative.
So negative 3/2. So we have square root of negative 3/2 t, and then minus 4/3 plus 1.
Where'd you get 4/3 from?
From this 2, we'd have to have a, before we could factor, pull this out, we would make it like 4/2. And if we're pulling out a negative, then it's going to turn negative. And then that's just what's left behind. So the transformations are to reflect it over the y-axis, a horizontal stretch, by 3/2, and then we have to shift right 4/3, and up 1 unit.